Hi everyone. Um, in this tutorial, we're going to be looking at how to use the Grasshopper WASP plugin to create some basic low-res component aggregations. So these files can be found in the student package. I'll be using today the 001 basic component aggregation, as well as the 001 basic component aggregation Grasshopper script. So first thing to do is open up Grasshopper and then open up the Grasshopper file, basic component aggregation. So this is going to be an introduction tutorial on how to set up a component, set up the connection logics, set up a detailed aggregation, set up the rules, and then by the end of it, we will have some sort of complex aggregation like this at the end of the tutorial. And then I'll show you how to bake as well with using Elephant as well as different materials and layer attributes. So first thing to do, we're going to do is we're going to have a look at the Rhino file. I'm just going to minimize Grasshopper. So I've set this up basically in such a way where all your inputs for WASP are under the input layer. And the first thing we're going to have a look at is this idea of a, so I'm just going to hide everything, this idea of a voxel. So a voxel is basically a mathematical structure defined by X, Y, and Z values. So basically a voxel size can be, in this case, we're looking at a 6 roughly by 6 by 6.5 meter voxel, but then it could range from anything. We could do a 3 meter by 3 meters by 3 meter voxel, and that would be like what that looks like. And so think of a voxel, the voxel structure, as basically a giant grid where we can manipulate each cell of the grid and its size. So when we refer to resolution, what we're referring to is basically the size of the voxel. So in this case, the resolution is 3 meters by 3 meters by 3 meters. If I want to go higher resolution, it's basically the lower the size of the X, Y, and Z value. So you can imagine at the moment I've got, if this is my, say, 3 meter by 3 meter voxel cubes, I can also create the same sort of geometry, but out of voxels that are 1 meter by 1 meter by 1 meter. But what I'm going to need is I'm going to need a lot more voxels to make up this larger object. So you can see here. Now, globally, it's the same, but one is made up of a lower res voxel, the other one is made up of a higher resolution voxel. So that's a rough explanation of what voxels are. If you think of like Minecraft, those kinds of games, they all work off kind of voxel resolutions. So this is what we'd call a symmetrical voxel, because each size is the same. So I'm just going to delete this now. But you'll find within your when you're designing a component, you might want to have irregular size voxels. So the first thing that we start with here is a voxel size. So this voxel is a 3 meters by 6 meters by 3 meters tall. And so what this does is it basically defines the scale of your component that you're working with. And as we're designing kind of at the scale of an architectural tower, we're really designing a module, a building module of the tower. So this is kind of the scale that we're working with at the moment. So it's really important to understand the scale that you're working with. So if I, for instance, made this in half, that means then we're scaling it, the module by half. So I just have this here just so you can visualize kind of the scale that you're looking at when you're starting to design your building component. So through this tutorial, what you'll want to do as well is sort of have a play with designing your own building component that you can use to aggregate with Grasshopper WASP. So what I like to do is just roughly model out the voxel size, and then I use the silhouette component, and I'm going to hide this voxel just to get the voxel lines. So this just basically allows me to see the voxel, but then also design within it. And for this tutorial, I'm just going to design a very basic component, which I've designed here under basic geometry, whereby basically I'm just giving it a slight angle, and you could change the angle, etc. And then what I'm also doing under detailed geometry is I'm just very simply delineating between what is solid and what is clear. So I've given this kind of voxel shell, component shell, a bit of a thickness. So I'm just using 150 mil thickness roughly, and then a glazing opening for now. As the semester goes along, your components will get more complex, but it's really important when we first start this exercise to start with the basic level of detail, and then we work up and we add complexity, because if we start too complex, then the outcomes aren't going to be as complex. So the whole idea is having simple inputs and complex outputs. So I'm going to go back now, and I'm going to just have a look at our basic components, and we're going to talk about connection logics. So one thing that is a good thing to do before you start thinking about when you're designing your component is also thinking about how you want your component to connect. And so by connections, what I mean is simply, if you start to copy and move things around, say like this, and then like this. So now we've got, a few ways where the faces of our geometry, so this face and this face, they're connecting through some faces. And so through this, I can start to understand, where the connections need to be on the faces of the geometry. But then also I could start to change the design of my component if things weren't particularly lining up, or, I wanted to change things aesthetically or in the angles, etc. So once you've established that base level of component, the next thing we need to do is establish our connection logics. So that's here, and they look like this. So within Grasshopper WASP, and I'm going to go back to Grasshopper now, we're going to focus in this part of the tutorial on this yellow and blue part of the Grasshopper script. So within Grasshopper WASP, there are a couple of things that we need to first establish. So if we go into the Grasshopper WASP tab, you'll see that we've got a number of different libraries. So the first thing we're going to want is a connection from direction component, and this is all laid out for you, but I'll just show you where they are. So this is in elements. So we're at the moment, what we want to do is construct our part. So basically we don't know, Grasshopper doesn't know what the part is, and the part being the component, and we want to construct the component. So there are really three main things that we need to tell Grasshopper what constitutes this component. The first being the geometry. So we're going to use this gray basic block as the geometry. The second being the center of the connection points. So those are these points here. So these are the points where if I start to copy this component, at this point, I'm going to say this connection is going to occur with this point here. So you can see that's the connection. And then if I go into ghosted mode, the next connection will be another connection would be like this, and then another connection might be like this. So that's going to be basically where at which point of the face the component is actually connecting to. And I can manually model this, and I can also move this around. It doesn't have to be in the center of the face, it could be somewhere else. So what is also good to do is basically start to think about, when I copied this one over here, there's this kind of weird kink, right? So I probably don't want that kink to be there. So what I really need to do is I need to move this connection face here to be in line with this. So now when I copy this component over to this connection point, now there's no kink and they're going to be flush directly. So things like that, when you're designing a component, you can think about in terms of connection logics. So if we go back to Grasshopper now, that's the first thing, is the geometry, and the second thing is the centers. The next thing it needs to know is really which direction is this connection happening. So in most cases, the direction is going to be going up. We generally want to show the direction is going up and away from the point. So one way we can check is if we just type dir, you'll see in Rhino, you'll see that's the kind of direction that the component, and then these ones are going that way, and we can flip these if we wanted to. So that's the kind of three things that are needed, and I'm going to set this up now. So the first thing we do is we just select and input our geometry. So this gets fed into our connection from direction component, and basically there's a final component in this yellow section which basically houses all our component information. So it houses our geometry, our connections, and our attributes, which I'll explain in a bit, as well as what the name of the component is. So the next thing we'll do is then we'll set referencing our points. So and then I'll press enter. And now here's something important. You'll see below in this yellow section, we've got a points component here. If I just toggle this on, it's going to show me, remember when in previous components I've talked about tutorials, sorry, I've talked about the list and the order of the list in terms of data. It's important when you reference in these points that when you then go to referencing the curves, that the corresponding point, so 0, matches with its corresponding curve direction. So I don't want to have 0 match up with 2's curve direction. So I want to just follow this point list to make sure that each curve and point connection corresponds. So I'm going to go set multiple curves, and then I'm going to follow it. So 0, 1, 2, 3, 4. So now you'll see it's highlighted, and that's all we need to do for this yellow section. Then the next section, basically what we need to do is, what we're also going to do is we're going to add a detailed part of the component. So right now we're just dealing with our basic geometry. I'm going to add this detailed section, and you don't have to do this now, but I'm just going to do this now for the Grasshopper. We can aggregate without it. So you can just go set multiple geometries. And we're going to turn that into a mesh, and we're going to give it a name, and we're just going to make sure this is true. And this component basically stores this information and passes it into this part component. So that's basically all we need to do to set up our component. And as you start to aggregate, you'll notice that you'll come back to designing this, changing the connection logics, etc. So the next thing that's important is the rules. So what are the rules that govern the aggregation? So sometimes, I might say, I don't want 0 to connect to 1, and I don't want 0 to connect to 4, but I want 4 to connect to 1, and so on and so on. So in order for the aggregation to work, we need to establish these rules or connection logics. So there are many ways to do this in WASP, but I found that the best way to do it is first to see all the rules, basically. So if we zoom out, you'll see here, and you'll see here, this is basically, here, this red part, this is basically all the rules coming from the connection logics I've defined. So the connection logics being these points and lines. So you can see it's going to spit out basically all the rules, and this comes from this component here, the WASP rule generator. And within this WASP rule generator, there's a couple inputs, so we can choose to create rules between connections, meaning we can have rules where if we're doing a multi-part aggregation, the connections will also be created from the same component, and then we can also create rules between the same connection. So I can say 0 connects to 0 on another component. And then type and grammar you don't need to worry so much about. So if I go back to this rule generator, so those are the rules, and then what happens is this component here basically allows us to visualize the rules. So I can make this bigger and smaller if I need to. And then this basically just makes sure these are true so that we can see the index of the rules and the type of connection, and I'll explain why that's important. And then this last part here is basically showing us the two connections as well as the text. So looking at the rules that have been generated from the rule generator, you can see that not all, if we're just from a kind of spatially inhabitable viewpoint, not all connection types are going to be useful. So if I zoom in, this one isn't going to be useful because it's basically an angled floor. This, if I project ahead, some of these might not be useful. Maybe some of these might not be useful. There are going to be some rules that aren't going to quite work. And so this is a good way for us to visualize in 3D what those connection logics are doing and their subsequent kind of connection states. So then what we can do, if we go back into Grasshopper, and this is why it's important to keep on this true, is we can look at this value. So you see this is rule 0, rule 1, rule 2, rule 3. And then we can basically go and we can choose our rules that we want. So let's say, I don't want rule 0. I don't want rule 1. Maybe I like rule 2. I like rule 3. I like rule 9. What I can do is in this panel that I've got here, I can start to specify which rules that I want. So I like rule 0. I like rule 9. I like rule... What rule do I like? I like rule 6. Oops, 0, 9, 6. I like rule 12. I like rule 15. And let's say I like rule 21 and 23 and 24. So now basically I've got these rules that I've isolated. And what I can do is I can then also take another list item. And I'll just do a rectangle. And let's just take this off. So basically, these are the rules that I'm selecting now. So you can see I've selected basically these rules that I'm highlighting here. So then now that I've got my rules selected, now I'm ready to aggregate. So this first half is really about setting up all your kind of parameters for the aggregation. So the rules, the component, what makes the component, the connection types, etc. are the detailed component. So then this next half is basically the aggregation engine and then visualizing the aggregation. So all of this information gets fed into this component here. So this is the kind of aggregation engine that drives the algorithm. So there's a couple of inputs here. The first one being our part. So that is this yellow section here. So the part. So that's telling the aggregation engine what component are we aggregating. The second will be the previous, which I'll explain in later tutorials what that is, but for this purpose we don't need it. The third input is the number of parts, so how many parts we want to aggregate. So for now I'm just working off 30. The fourth is the rules. So this comes as we're sectioning off and selecting particular rules. This list item component basically serves as where our rules is. So you can see it's got 8 WASP rules. So we're going to put that into our rule input. Then basically a seed value. So a seed value is just a fixed number where basically we'll randomize the aggregation depending on what the value is. And then the category and then the mode and global constraints I'll get into in a later tutorial. And then finally a false and true reset button to reset the aggregation. So I'm going to click reset and you'll see, hopefully, if I turn this on, you'll see there now when I previewed this on, my aggregation is starting to take place. And if I start to increase the amount of components, you'll see that it's starting to aggregate further. And if I start to change the seed and press reset, you'll see it basically will change the type of aggregation. And so this is a pretty good way of testing quickly different iterations of aggregations. And so what we do now is when we've aggregated it, WASP basically needs to convert the WASP kind of geometry back into Grasshopper geometry. So we do that by getting a WASP get part component, get geometry component, and that's going to get you this geometry here. And I'm just doing a simple move operation just to get it out of the way from our initial input component. So that's just controlled here, but you don't have to use this. And then we can also preview this on render mode, so we can actually see what's doing. So now, I can look at this aggregation and I can say, well, I don't particularly like when it does this, for instance. So then what I need to do is I need to go back in and I need to have a look at my rules and understand what's going on. Why is it doing that? And it's probably because of a particular rule, which is probably this 0. So let's delete 0. And we'll reset it. And see now it's it's different. And if I start to change it's going to give me something different now. So now it's going back and forth, and we've got rid of that. So there's a kind of going back and forth between designing the component, the connection logics, the rules, and then aggregating as well that you need to do. So then once you're kind of happy, so I'm going to say, let's let's find an aggregation that's interesting, and I'm gonna change maybe some rules as well, just to give you guys an example. I see. So we've got this one, 25, 23, that's giving us a bit of problems as well. And maybe I want to incorporate number 17. And maybe number 2. So let's go and reset this. So now we're getting something maybe a little bit more interesting in terms of, you know, spatially. So when you're kind of judging the aggregation as well, you want to not just judge it based on kind of these kind of purely technical things of connection, etc. But we also want to look at this aggregation for its possibilities for architectural space. So, you know, I'm looking at this and maybe there's, you know, there's these rooftop areas, there's these outdoor areas, there's this kind of weird interstitial spaces. So I want to look for the opportunities for architecture when I'm aggregating. I don't just want to aggregate kind of blindly. So I might keep, you know, and this is what we call the design search. So you're kind of searching through this algorithm for particular states of architecture. So, you know, maybe I'm interested in this. The key thing is to not be too precious about each aggregation, and it's more understanding the tool and what a particular connection logics and things do. And you want to really capture each aggregation output as a taxonomy, so that we can see kind of your thinking behind the aggregation. So let's say now I'm kind of interested in this kind of quality. The first thing I can do is I can, first of all, using Elefront, just bake this basic aggregation. So I can call it iteration, whatever. I could also put the seed value, so 313, just to title it. And then all I need to do is press activate. And that's gonna, if we go into Rhino now, that's gonna create a layer called iteration that has all the iterations of that. It's gonna bake that geometry. Another thing that I might want to do is I might want to visualize the detailed geometry. So the way to do that is we use the ID, so the ID being what we name the detailed part, and we use this WASP get attribute by name, which is in elements. So it's going to ask for the parts, so the part out, so that's our aggregation. So if I grab a panel and I just show you, you'll see it's got the WASP part, the basic name of the basic module, and the ID, an ID value. And so we're going to basically isolate that ID value, and then I'm just making sure I'm moving it if I am away from this component. And then because we're dealing with two parts, so we're dealing with, this orange and then this glass part. We're going to be dealing with basically two elements, so two pieces of information. So the data structure here basically looks like, if you think of, it's going to be 252 lists with two pieces of information in each, with that being, if I grab my true viewer, see here, it's quite complex. The two pieces of information being the orange shell and the Windows glass. And then all we need to do is separate those two lists into its two parts. So the first being our shells. So we use a list item component. So a list item, basically what that allows us to do is retrieve a specific item of the list. So I can put this in here and I can say, well, I want list item number 0. So item number 0 here, number 0, is going to be that mesh shell. And then item number 1 is going to be that glazing. And then all we need to do is then bake using the elephant. Just click bake and bake. And now we've got, if I go back into Rhino, we've got our, I'll just turn off this. We've got our glazing and we've got our shell, and I'll give this a material. Let's go for this, and that's okay. And oh no, one. We'll give this material. Okay. Select objects, material. There we go. We'll assign this with a wood texture, and then we'll select objects, and we'll give this a bit of a transparency. And then now we've got a wood texture, and I'm just going to also properties, just turn off mesh wise so we can just see. So now we can really actually judge the architecture. So we can say, well, you know, there's some interesting spaces here, but what's happening here is maybe that's a light well. I don't know what that is, but you know, we can look at our things, and then from here we can capture all our aggregations. So that's the first basic script that you'll be using to create basic aggregations using the rule generator, connection logics, and component design, as well as then visualizing it with different kind of wood elements and glazing elements as well. In the next tutorial, what I'll go over is how we create multiple part aggregations. So not just kind of the single elements, but two, so we can get kind of more complex aggregations going, as well as then how do we put the aggregation within a bounding box so we can not have weird situations like this. I will say one thing as well, it's okay, you know, when you get an aggregation like this, really look at the aggregation like I'm doing here and look for its opportunity, what works, what doesn't, and don't be afraid to manually edit things. So I'm looking at it and, you know, maybe this doesn't work, so I'll put, now it looks a bit more like a building. You know, maybe this doesn't work because it's too cantilevered, and this doesn't work, for instance, etc., etc. So you can, don't be afraid to manually alter the aggregations. A lot of the time when we use Grasshopper, the trap that students fall into is thinking that, you know, when we bake the components, the model is done. But really what we need to do is also look at the aggregation that we're getting, and alter it as well with our kind of design ideas and sensibilities. So that's it for this tutorial. I'll be back for the next one.